Hello, everybody, and thank you for joining us today for Adam's webinar on the Qualitative Systems Exploration Model, or short QSEM. I speak to you from my home here, which is in Wurundjeri country, and want to acknowledge the very first systems thinkers of this land who have cared for it and shared a lot of knowledge freely in the past. And I hope we can do that generosity justice now and into the future. And I pay my respects to their elders past and present and extend that respect to any Aboriginal or Torres Strait Islander people joining us today or watching this recording later. Um, Before we begin, I'd just quickly like to do a plug for us here, the Oceania chapter of the System Dynamics Society. Hossein is online, is our president. Um, and the chapter connects systems thinkers, system dynamics practitioners and researchers and enthusiasts really across Australia, New Zealand, and the wider region with a focus on collaboration, learning, and community building. We have our annual symposium coming up in February. It's free, so head to our website, sign up, and come along either online or in person is even better. It's much more fun, and we can eat together and have coffee. And Melbourne is very good for coffee. Um, so now I'm really pleased to introduce Dr. Adam Hulme, founder of the System Science Lab. The System Science Lab is a business that consults, builds tools, and trains teams in systems thinking and modeling. And Adam's work and research has spanned across sports injury, public health, and more broadly, the challenges of understanding complex systems in real-world settings. So areas he has published extensively in. So go check him out. He has a real interest in helping groups make sense of complex problems using practical, rigorous, and transparent systems tools to aid practical decision making. And I believe we're about to learn about that much more. So he'll walk us through today through the qualitative systems exploration model, a participatory semi-quantitative approach that helps turn causal loop diagrams into clearer insights and potential areas for action. So adding rigor while maintaining participatory spirit of GMB. I'm really intrigued to learn more. Over to you, Adam. And
Oh,
thanks
thanks.
for coming.
Thank you. Yeah, no pleasure. I just thought then such a good intro. I think I'll make this very brief. I might just take 10 minutes. That was fantastic. Well, righto. What I'll do here is I'm going to share my screen, and before I do, um, I don't mind if people in the room
Mhm.
wish to put their videos on. If you're eating, that's fine. I really don't mind. If you're traveling, of course, there's nothing you can do. Um, but if you can, brilliant. I can just get a feel then for the vibe and so forth. Well, Miriam's sort of done a great introduction there, so I'll share the screen. Any issues at all, if there's any technical difficulties, please do break the silence and yell out. Just makes things a lot easier. All right. So can we all, and I'll move the panel there so I can see everybody. Okay, so thumbs up, we can see that. We're good to go. Um, the first thing to say as well is Hussein, Miriam, and the team there at the Oceania chapter do a fantastic job of promoting activities in the region. Um, and it's safe to say that um, because of that, we we can promote and advance the science of systems thinking and system dynamics ever more. So thank you very much for the opportunity. Hopefully it's gripping and people can learn something, because I notice in the room there's a lot of experts, of course, and people well versed in system dynamics and systems thinking. I mean, very good company. So crikey, the pressure's on. Let's see how we go. So to kick things off, what I'd like to do here, if I can get going, is first things first, is probably just a very quick intro on current work and activities. So yes, founder of System Science Lab. I'm working on an ARC fellowship in my other capacity at the moment in SD modeling, looking at the rural health workforce shortage and using computational modeling there. And had a recent trip to Norway, which was fantastic, as we were discussing before there. And really the point of that trip was to upskill in soft systems modeling and modeling fuzzy factors and variables in computational models, the intangibles, if you will, and doing that properly with anchoring, normalization, and scaling. So I have a very strong interest in always learning, always upskilling, and actually delving into the quant side of modeling. Um, And that's me on the top left there, sort of first time in Bergen, beautiful place. And Birgit Kapinski there and Jefferson Rajar, they're sort of, I went over to see those two and the wider team. Yeah, and it was just a brilliant time and such a quaint little cozy city. Some of you may have been, but I thoroughly enjoyed it. Uh, it was fantastic. So, look, I'm an academic at heart, so rapid definition of terms to kick things off. I think it's important. Um, and I'll try not to slip back into old terminology here, but when I refer to participatory SD, I just want to acknowledge that there are three traditions in system dynamics that you're probably aware of. So group model building, participatory SD, and community-based SD. And I think for the purpose of this presentation and moving forward, I'll just refer to group model building, GMB, in those moments where it's relevant. And there's a rich history there, a lot of tradition. It's great. Qualitative SD, when I say that, when I refer to that term, I mean sort of non-simulated applications, notwithstanding the fact that qualitative aspects of system dynamics, and I think I've put in here a special issue from last year that you're probably aware of in System Dynamics Review on qualitative modeling. It's really, really critical to the formal modeling process. So big fan of course, of both non-simulated and simulated approaches for various reasons. All right, jumping in. If you don't yet know or aren't aware, what is QSEM? So the first two bullet points there are probably the most important on this slide here. And the key word is exploration. So it really helps end users, consumers, participants in that GMB setting to build familiarity and to really support that sense making of causal loop diagrams. And the key thing there is this notion of impact, control, and time delay scores, which you'll see will play a role in QSEM, a significant role. And that's to identify key factors and feedback loops. And really, it's to address this third point here. Like when we see papers published and reports and so forth, why do people tend to focus on, a particular reinforcing loop or a set of reinforcing loops when there could be many? Now, of course, that comes from expert insights and the rich discussions that I had. But QSEM can just support that and provide justification and that process traceability around that. And it's applied at that sort of late stage conceptualization of the systems modeling of the qual process. When you have sort of a participant verified, if you will, or expert approved CLD, noting that it's never truly finished. The journey is more important than the destination to some extent. And of course, it's very iterative. So if you move on to formal modeling, then you may need to go back and revisit your conceptualizations. It targets those non-simulated SD applications and integrates into GMB processes. And that's the key point here. There's a lot more work to be done in this space. And I'd be keen to see how others may move forward with QSEM and actually use scripts from the GMB protocols to enhance QSEM as well, and vice versa. And the need, I suppose, I've always taken a strong interest in reliability and validity and thinking about the practical side of life. So what do participants and end users and stakeholders think about systems modeling, and how do they understand the process? And what do they get out of it? Because we're guiding them as the so-called experts, and that's always been really close to my heart. And really, it emerged out of this need to get more from our causal architectures, just to get a little bit more in that non-simulated context. And I'll talk later about how, as you're aware, how that's booming at the moment and how we're seeing an explosion of CLDs. And so what I'll move on to is just show this continuum. I thought I'd do this late in the day, this slide, because I thought, where does QSEM sort of situate? Where is it positioned, if you will? And it's not perfect and it's not completely exhaustive here, but you can see on the left, you've got your non-simulated applications. In the middle, your sort of quasi-simulation ready approaches, and then your full simulation to the right. I've just highlighted green there because FCM and computational system dynamics you'll probably be well versed in and strongly aware of. And there were a couple of approaches there, semi-simulated Marvel and diagrams to dynamics. And so there's this movement, other methods of gaining traction in response to, bridging that divide between the non-simulated and simulated. I think we're going to see more activity in this space, perhaps over the next few years to decade. And yes, so it's situated. But the one thing to say on this slide here is that just because something is non-simulated, that doesn't necessarily mean it's non-numerical either. So QSEM would be trespassing, further into that numerical category, if you will, but it's not purely non-numerical. Obviously, we'll see there's some basic equations and maths tied to it. And I've put this slide up here to say how important simulation is. And I've gone back, 2-3 decades into the system dynamics review and into the literature and found some fantastic, and you're probably all aware of them, but fantastic articles, between some of the big hitters around the use of CLDs and systems mapping from Richardson and Hulme and Coyle and Lane and so forth. To be across those sorts of debates and arguments and so forth. And I think I'm of the standpoint that CLDs are extreme, and mapping tools are extremely important for articulating your dynamic hypothesis pre-simulation or communicating the results like in an expositional sense after you have a formal model. That still occurs, of course, but what we're seeing more and more now is, especially in public health, medicine, and implementation sciences, is standalone causal loops being published with perhaps an idea that they'd be used as a formal modeling, a precursor to formal modeling. But I'm not always sure in those projects how much formal modeling is done. So it's QSEM sort of responds to that space there. All right. And what I'll touch on now is sort of the remainder of this webinar will cover the origins of QSEM and that manual process that was tied to it, and then that automation midway point. And I think I saw Karim online there. Stella played a vital part in that process before I ended up with that full stack web development software solution. And so the webinar here will cover that technical process that led to QSEM as it is today. Of course, it's still very early days and is in that beta testing phase. The first 2 phases of QSEM will be outlined. There is a third phase, an archetype identification and analysis phase, that's still being sort of developed and packed into the actual software itself. But there is a 7-step tiered ladder that can support people with sort of drawing out or extracting archetypes from non-simulated models using a systematic and transparent process. Now, when I refer to this paper, oh, that's in the paper or that's in the guide, there is a paper that's been under review now for some time. It's been sort of eight months. You know how these things are. And so I'll be very excited when that's released because I can just send the technical guide out and receive feedback on that from people and get a general vibe. I will go through the software at the end, just a basic demo. And I won't get into the technical and software aspects there. I can refer any questions on to a few people who have supported with the development. And I do appreciate your patience given the mixed audience. We may have experienced modelers in the room. Well, we do have experienced modelers. We may have people just getting into SD as well. So I'm talking to the converted. Appreciate your patience. So in terms of the QSEM methods track, where it started and sort of where we are, it was born out of commissioned work, and I'll talk to that very briefly. And that led to sort of 7 to 9 sort of subsystem CLDs. And really, we had 12 months to do this work, as you'll see. And so the idea was, how can we get more from our non-simulated applications here under these constraints, under this 12-month timeline? And so we can also fulfill the needs of the stakeholders. And that led to sort of this manual process with existing software solutions and then spreadsheets and so forth to actually identify key factors and feedback loops. And I thought, oh, this is interesting, and the stakeholders are enjoying it and can follow that process. So I thought, okay, there may be some value here in automating all of this. So look, we're not at the top of the mountain by any means, or the tip of the iceberg, however you want to phrase it. Hopefully it's not a downward fall or descent, but I'd like to go a bit higher and climb to the peak if possible. We'll see how that goes. So in terms of the origins, the backstory there very briefly, with Dr. James Nobles and Dr. Duncan Radley, we worked with the Welsh government to basically try to identify factors that influence dietary choices of Welsh households. Identify, perhaps that word is loaded, but those potential places for policy intervention, extremely challenging unless you do formal modelling. Nevertheless, we wanted to provide the stakeholder with some insights and evidence and so forth and take them on that process with the goal of encouraging a shift toward a healthier and more sustainable population diet. The project was great. It was fantastic. And we're still in touch with the stakeholders and thinking about doing some more work there. We had 12 months. It was a very tight deadline. So the QSEM process itself, there's a fair bit here on the page. The text may be small, I do apologize, but the key things here is you've got model development. So you have a sort of a CLD that is, so to speak, complete. You're happy with your actual model itself. So you can use pre-model scripts there, post-model scripts from the GMB context. Perhaps you've used existing data and information to develop your CLD. You've taken a mixed methods approach. Whatever it is to create that model, you have a model. And then QSEM phase 1, the system factor classification, comes into effect. That's the first port of call. And then from there, in the green box, you've got phase 2 loops of interest. So you're starting to dig into those feedback loops and dynamics. And then phase 3 is your archetype identification. So as I said before, we'll cover QSEM phase 1 and 2 today. And you can see out of each phase, you have things like phase 1 under there. You've got your coded CLD, factor typology, and system grid. And those outputs of each phase are used as the input to your group model building scripts, if you will, your post-model scripts. So I've put an example there of dots, nominal group technique, and reflective feedback, and how those sort of scripts can be integrated with your QSEM outputs, so sort of to enhance the scripts, if you will. And so we use a direct dependency matrix, so turning the CLD into a DDM. And then we look at system factor classification. And I'll go through this with you in today's webinar. We've got the time. Things like system grids and coded models. And stakeholders really like this. They like to look at a model and go, okay, that's interesting. This seems to be I'm going to use quotation marks here, but a steering factor. And, oh, this is a measuring factor. And there's definitions around what these are. And depending on and we'll talk about fuzzy weights, impact and control, but depending on the weights assigned to particular connections within your CLD, you'll actually see factor types change in your model. And then, of course, loops of interest. So I'm showing you how this started, of course. We don't have spreadsheets now. You can still use them, but this is how we got to, or I got to the actual software itself. And in terms of scripts, I've provided a little bit of an example here. On the left is your script, and on the far right is your suggested QSEM use. And you can see the description of your script is as it appears online in Scriptopedia, with Peter Hoffman's work and George Richardson and so forth, and Venix. And I mean, on the right is how QSEM might be used in relation to that script. So if I take model review, for example, here, which captures information about structure and feedback from participants after you have your model. Well, in this particular case, QSEM's dynamic loop register might be used to identify loops of interest to support that script. And, the discussion can then be had in the group. So I won't go on, but I'd love to be able to test this further and how we can integrate the scripts and QSEM further. That would be a really interesting area of work. And just a little bit on that contribution to reiterate the knowledge and practice gap. As I said before, it responds to this growing use of standalone, and in particular, these really large and complex models, these big spaghetti salads in the literature. And I suppose the die-hard old school, system dynamicists would think, this is not how we started, what can you get out of this? And so this tidal wave of all of these non-simulated applications, I think QSEM is there just to help that along and to say, hey, let's think about why we're highlighting these factors and feedback loops which form that system narrative. And in terms of practice, it really participants and end users, like with the Welsh government, they understood every step of the way, with QSEM. As soon as you move to fuzzy cognitive mapping, which is, I think, a really interesting method, perhaps the interest is not quite there so much. It serves more of as a black box, whereas I've tried to make QSEM as transparent as possible. And so on the right there, I like the way this CLD is presented, this converging perspectives CLD. It's a beautifully presented CLD. It has 207 loops in it, and I think the authors sort of highlighted off memory 24 or 25. And I wondered why those 24 or 25, and there's nothing wrong with that if that came from the group, the participants themselves, and there was a process of deliberation. QSEM would say this 25 loops, these have been emphasized and discussed within our setting prior to formal modeling, due to the group's consensus around impact, control, and say time delay scores that we assigned to all of the connections in the model. So it just provides that reasoning and justification for why you're selecting them, those elements. And I thought I'd have a little look as well. I'll put my money where my mouth is to look at how, and this is just PubMed, but how the use of CLDs in just title and abstracts has grown over time. And you can see here that it's gone from 24 to 57 in the last year, just in PubMed. I think in Web of Science, yeah, that's there as well. It's gone from 99 in 2020 to 177 in 2024. So we're seeing a lot of these sorts of models here published. And I suppose, I think on the next little part here, I have emphasized that there has been work done, in particular Turner and Goodman's work, sort of actually saying, hey, if you're presenting a non-simulated model, do use your loop labels and your conventional naming of your loops as well, so people can understand the model and try to present the model nicely. Elegant and parsimonious models attract attention, whereas all of the messy models can be hard to understand, quite intractable in terms of problems. And these articles here are from that special issue. And so I read these articles in detail and thought there's some really good information and approaches in here, and tools and techniques and so forth. And what QSEM does is it takes a number of those promising approaches and sort of puts them under one roof, and then adds a few new things. And so I really was inspired by the good work published in the System Dynamics Review in that special issue for QSEM here. And there's a lot around the application considerations of QSEM, but I'll touch here very briefly on the intended audience, workflow options, and then I'll get to software use. And so perhaps it goes without saying, but the intended audience for QSEM are researchers and modeling practitioners. And we have a technical guide and all of the electronic spreadsheets. And as soon as that, as I said, the paper is available, all of this will be released with it as well. And I'll briefly go through the spreadsheets as well subsequently. In terms of QSEM workflows, there are 3 different workflows. The time it's taken to apply each one, like QSEM full, can take a lot longer than QSEM light. That's all outlined in the paper, and I'm happy to have any questions on this or explore this further afterward. I'd have to cast my mind back to the specific nuances around each recommended approach, but you don't have to apply the full QSEM protocol. There are shorter ways of applying it as well. And Stella's are absolutely fantastic for simulation modeling. It's brilliant. I spent a lot of time in Stella, and initially in the early days, because Stella's, it's not designed for the reasons QSEM exists today. QSEM is sort of an adaptation, if you will, of system dynamics in many ways. It's a systems thinking platform, not necessarily a system dynamics, although it shares principles of system dynamics. I'll show you how I use Stella to sort of enable the identification of feedback loops and use its CLD loops panel. So on to sort of QSEM phase 1 in terms of that framework context. We're at system factor classification here with the direct dependency matrix and pairwise scores and impact control and so forth. So it draws on a lot of existing ideas, phase 1, from futures research and scenario planning and management, and there are various phases in scenario planning and management. But it takes, I think it's phase two, where we look at the idea of a cross tabulation in system grids. And it uses the cross impact matrix technique, but it uses a direct dependency matrix. So it just looks at sort of first order relationships. It doesn't use, I think it's where matrices are multiplied over and over until convergence and stability is reached. In terms of the micmac literature, that's really fascinating. I spent some time reading about that. It just uses a direct dependency matrix. It doesn't use multiplication. And so what we do is first you have your model. So you've got your CLD as part of your group model building activities. You will then assign impact and control fuzzy weights, impact and control scores to each connection in your CLD with your stakeholder group. It's actually a really interesting process because you have to move the discussion along with the participants because they can actually spend quite some time saying, oh, that's really impactful. That's a 3 for impact between factor A and B because, and then there'll be a discussion elsewhere in the room and there'll be disagreements and agreements. And control, and I'll move on to this now, but control is about governance potential. Like just because something's impactful in the model, the relationship between two factors, do the stakeholders themselves feel that they can do anything about that relationship, either at the factor, on the factor itself, or via the relationship. And so in terms of that impact control definitions, the stakeholders in the Welsh Government project were asked, what do you feel is the extent of the impact of the driving factor on the receiving factor? You know, small, medium, or large. But it's fuzzy. You know, we're in the qualitative land here. It's useful, but just acknowledging that these are fuzzy weights. Control, to what extent is it possible to influence the receiving factor by intervening on the driving factor or its effect? And this goes from 0 to 3 because whereas impact is 1 to 3. And that's because if you have a relationship depicted between two factors, you've already, at minimum, consider it to have a degree of impact. Whereas for control, it can actually start at 0. Just because something is impactful, you may not consider yourself to have any control. So you go through and you assign all of the scores. You don't need a participant group to do this. Perhaps you could use existing literature and information and data to assign your impact and control. I just think with systems modeling and methodology, it's really important to be transparent for replicability, and so the reader knows exactly how you've arrived at those scores and those weights. And in terms of time delay, this is actually a newer addition. So we have impact and control, and now, as we'll see, you can also assign sort of a speed score, if you will. And so participants are asked, you know, how long does it typically take for the impact of the driving factor to show up in the receiving factor? No delay, short, medium, or long. And there's flexibility around this depending on the boundary and the scope and setting of the model and the problem that you're modeling. And you can see here on the right, this is actually from the software. The impact, the control is here, and time delay there. And that's used later for loops of interest. We don't say loops that matter. That's stellar. We cannot do that. But it's loops of interest. It's, you know, we have some loops here in the model. Let's explore them. That's all it can do. So you've got your CLD with your impact and control scores assigned to each connection. And what in the early days anyway, this was very painstakingly slow and highly manual. So you actually turn the CLD into a direct dependency matrix. So factors down the side, down in the column, and then across the top as well, or in rows and across the top in the columns. And you can see impact and control. So you basically, you know, clean and sustainable processing alternatives here, a factor in the CLD on intergenerational farming beliefs. The participant group considered that to be, you know, have moderate impact on intergenerational farming beliefs. Control, perhaps less so. They put a 1. And so I did that for all of the CLDs in the project. And then what you do is you basically sum up your and you can compute active impact values and active control values, and then passive impact and passive control values in the rows and the columns, like so. And then from there, you basically carry over your AIV, PIV, ACV, and PCVs and put them into the 4 columns here. And then effectively all you do is you have a raw weighted active value and raw weighted passive value. So you've weighted impact relative to control, and then you normalize them, and then you can plot them onto a system grid. So it's basically dead simple. You just compute your two score values, combine impact and control with your weight, rescale it, and then you repeat that for your passive values. So it's just first order, like local influences from a DDM, but it's a good first pass for stakeholders to go, okay, this factor could be interesting, or we're starting to understand now why that may be considered to be, a driving factor, so to speak. And it's important to say that, as you can recall before, we went from a scale of 1 to 3 and then 0 to 3, and time delay was 0 to 3. I'd be really interested in looking at the sensitivity and the outcomes if we were to change from, say, 1 to 7 or use a scale of 1 to 5 instead. That could actually really change the outcomes here and where factors are on that grid. So in terms of factor classifications, you can see definitions here. Steering exert relatively strong, keyword being local, influence and control over other factors, but still it's the relativized in relation to all the other factors in the model. And these factors, I should say here, may be resistant to being influenced and controlled at that given point at which the model was developed. Of course, we're not dealing with temporality here at all. This is just at the moment participants and stakeholders and teams work on developing the CLD and analyzing it. Measuring factors, they could be indicators of system change and monitoring points. Ambivalent factors, they serve as both drivers and responders, and then autonomous operate relatively independently in the system and are fairly stable over time. So that's how we and of course, depending on the weights assigned to impact and control, the factors will move around that system grid. Again, in the early days, in terms of the spreadsheets and approaches, I just developed a simple drop down there where people could actually change, the weights assigned to impact, and the inverse then would apply to control. So 100% given to impact would be 0 to control, nice and simple, and then normalized. But of course, every time the factors moved around on that system grid, I would have to update the colors. I'm okay in Excel and spreadsheets. I've got sort of moderate skills, but nothing too advanced. And so every time those factors moved around in that space, I'd have to update the colors of and the reason why that was important is because up here in the early days, you can see I would have to go back to the actual model and update the coding on the model itself, which took a lot of time. But of course, that's all done for you now in the software. So all of the colors, the impact and control, and how factors can actually take on different colors and coding, that's all done automatically. So it's really sped that process up. But of course, I couldn't have got there, to this point here without having explored and gone through that manual process. All right, take a breather. I think we're on to phase 2, loops of interest. And so here we have things like the dynamic loop register. We start to look at further quantitative results like a normalized loop composite value, normalized steering factor count, and then a conditional independence value to prioritize relatively long and rare loops or relatively short rare loops. I have subsequently, not to confuse this captive audience here, I have actually swapped out the normalized steering factor count for that speed value, conditional delay value, but I'm thinking about putting it back in. So I'll talk to you about that as well. So loops of interest, what is it? So it draws on the same direct dependency matrix from phase 1. So we use that DDM, but this time certain values are piped through to the dynamic loop register to actually look at the impact and control strength of loops, as well as other metrics, and we can change those weighting coefficients around. And it really is to explore all the loops within a model. And the key thing here is, as we said before, it's because there's been this explosion of non-simulated models in the literature, and these models are extremely large and complex with sort of 40, 50 plus factors and hundreds of interconnections. This is where QSEM starts to shine, like when you start to actually make sense of that model. If you're doing a small and elegant model, great. you can just interpret it, via traditional practice, no problem. But QSEM really helps with large models. And so the three metrics, this is after you prioritize impact or control, is the loop composite value. So this is multiplicative. So really, it's that loops with relatively strong impact and or governance potential. So we're multiplying those scores around the loop. It's like a single pass loop gain. It doesn't look at, I mean, there's been some really advanced algorithms and mathematical approaches and PhDs in system dynamics, in the past that have actually looked at loop gain, and it's really good work. This is very simple in comparison. This is just one sort of cycle around the loop. But people understand it. That's the important thing. The stakeholder group, they get this. Normalized steering factor count. I described this initially as sort of, I'm thinking of putting it back in, but as identifying highways that pass through major cities in your model. So if you think of those strong, impactful or control-based loops that happen to go through steering factors from phase one, that could be of interest, and it would be interesting to also observe the discussions that come from that. And then your conditional independence value is just looking at highlight shorter loops that are minimally shared with other loops. So if the loop is shorter, it's got less chance to overlap the factors that are contained within it with other loops. So it's correlated with loop length. So what I did was I multiplied the sort of the normalized independent loop value by the number of factors in a loop. And what that did is it revealed longer loops that remain, relatively speaking, structurally distinct. And so if you look at models that have subsystems, typically if you switch the conditional independence value to prioritize longer loops, you'll see loops that go around through many subsystems in a model, and it just highlights those more readily for you, so you don't have to hunt for them in the architecture. And then this was the delay, the time delay that was recently added here. And so top right, you can just see this is an output really from one of the loops in the model. So the group assigned, a score of 3, very slow delay between two factors between here, very quick here, and no delay here. So the effect is almost immediate. So this had a lot of factors within this loop, okay? And that produced basically a raw loop delay value, simple sum, 25, nice and easy. And then the adjusted loop delay value is you basically take your raw loop delay value over the number of factors in the loop, and it gives you an adjusted value. And then I basically normalize that. If I want to identify longer, more independent loops, I just invert the this value here. So it just prioritizes the loop set differently. And so that's what these scores are here. And in the actual software, as you'll see, if you assign a 3 to the time delay between factors, you'll get 3 sort of notches on the arrow. Whereas if the delay is relatively quick, you'll just get 1. So participants can see that visually. And the group like that. All right. And then this is what the dynamic loop register actually looked like in the early days. So I had here basically all of the loops down here on the left, the loop length, and then here are basically your metrics. You normalize loop composite value, steering factor count, and then your conditional independence value. And then you could change your coefficients here along the top to sort of explore all the loops in the model with justifications and reasoning. And when you press this, it was a macro. So when you sort the loop register, you'll resort this column here based on your weights. And you can see here that balancing loop 8 with 12 variables happen to be the top loop according to these weights and what you've assigned. Nice and simple. And just very quickly, how I got there for those who like to nerd out on this stuff. I mean, I certainly do. So hopefully don't put some of you to sleep here, but I wanted to show you how I actually got there with the dynamic loop register. So I first created the model in Stellar. I ensured the CLD loops panel was docked. I added the loop labels to every loop in the model, because adding those loop labels allows you to then view them in the documentation viewer. I imported those text-based loops into a spreadsheet, and that eventually formed the DLR. I cleaned each loop, and I added a space between each each factor within a loop. And what that space was for, that was critical, is because I added a new fact column in the direct dependency matrix to identify a new score, which would be used to identify the strength of connections within a loop. And that was piped through to the dynamic loop register. And it looks sort of like this. And Stella was fantastic for this. Step one was your CLD. Use my loops panel here. Make sure that was docked. And then I assigned labels to all of my loops, like so. And then I could see them in the documentation viewer there. And then I added new cells to the direct dependency matrix. So next to impact and control, I added basically to capture the impact or control. It's a weighted active score, I called it, between each factor. And those scores, depending on how much weight you assign to impact and control, were actually piped through between each factor within a loop here. So that's how I could compute that loop composite value. All right, I'll quickly move on from that. And then when you actually present your loops of interest results, when you actually have a CLD like this, I can now say that outsource to insource or farm smarter, not harder, or what's that one there? Deals, discounts, and demands. I can show the reasoning as to why I've highlighted those loops based on the qualitative input from stakeholders, which has effectively been transformed into a quantitative output. So I can offer justifications for why I'm focusing on those, and you can run multiple iterations of the dynamic loop register depending on what you're interested in. Of course, this is now done all for you, and we have the dynamic loop register in QSEM here. It's no longer a big spreadsheet. Thought it was there, a big spreadsheet. It's now part of the actual software, and you can highlight loops and so forth as with other software solutions. And so before we dive in, I don't know how I'm going for time, Miriam and Hussein. I think we've got a bit of time here. So,
You're right. Yeah, you're 45 minutes in.
oh goodness, okay, plenty of time. So in closing, we basically, well, I would like to say that basically it is an optional and complementary approach. It is just another tool or approach amongst many, many good solutions out there if you wish to use it. And if you wish to do obviously more rigorous modeling and actually identify policy levers, then you would need stock and flow modeling and more advanced software solutions. And really addresses that knowledge and practice gap we mentioned before. And the benefits in a nutshell of QSEM would be such that it allows you to go through a model and have debate around the metrics that QSEM reveals, and may identify those factors and loops of interest that then could be sort of targeted in formal modeling or could support that formal modeling process. And I think the big thing here is that participant facilitation benefit. Sometimes in a group you have power imbalances and louder voices may come to the fore. If you were to sort of assign impact and control or time delay scores using a consensus approach, like a Delphi approach, where everybody is allowed to weigh in on what they consider to be important, QSEM sort of can cut through that power dynamic and allow for those sorts of outcomes. And the big thing, I like to say this, but it's that hands-on engagement each step of the way. So the government, the Welsh government, understood that whole process there. I mean, I've delivered it in 45 minutes, but by the time we'd spent a number of hours with them, they fully understood why they had factors highlighted in their models and the reasons for that, and also how they arrived at those feedback loops in the model as well. Like, why are we emphasizing these particular loops, and have we explored all loops? Like they understood it and they got it. And I've done modeling without QSEM with people before, and I've used QSEM in this project, and there's a lot more work to be done, but I found it to be very helpful in comparison to what I'd done before. The technical guide will hopefully be released soon, which is important for the theoretical foundations. And then I thought maybe if people wanted to, we could jump into the software and I'll just take people through it. That sounds good.
That sounds good. Do we want to just check in for some questions, maybe? Any questions out there? Please raise your hand, unmute yourself. Or just unmute yourself. Ah, you've flattered the masses. No questions yet. Okay, let's delve in.
Devin. I will just. Okay, so it's really hard sometimes to know sort of what level people are at in terms of their experience using it, whether they've registered and got hands-on. Obviously, I consider it to be um, a really simple approach, probably because I'm sort of well versed in QSEM now and have built it. But I can go through and just take people through the user interface and the software and how it all works, and I think that might be useful. So when you first load up QSEM itself, can you see my screen, Miriam? Is that all visible? Yeah. Um, you'll be greeted with this welcome modal. And if you press take the guided tour, you'll have a series of tutorial slides that you can look through. And effectively, they're delivered in a very layperson language, so they make as much sense as possible, and it covers all of these themes here and how to actually use it. If you wish to get back to that, you can actually show the welcome modal again up there next to key controls. And so I'll just refresh the canvas. So it sort of looks like this when you first load QSEM up. And so on the left here, you've got model statistics. And so as you develop the model over time, you'll see the model statistics box update in real time. And so as you populate factors and connections and loops, this will change. And it will also tell you how many reinforcing and balancing loops you have in the model, in terms as well as your polarities, with regards to connections. And now we've gone through the webinar, it makes more sense as to what these impact, control, and time delay scores are. So depending on if you've it's the frequency and proportion of how many small, medium, and large impact scores you've assigned. It just provides that feedback to the user across these three different score categories. And below that is your zoom control panel and whether you want your grid on or off for building. We'll talk about the spatial sixth sense when I've got a model up, but that basically allows you to always understand the footprint of your model and where it is. Across the top is your toolbar. So this is where you can add factors, like so, connect factors, and ghost different factors as well, like so. When models get large and messy, so that just assumes the role of this factor here. Undo, redo, reset canvas. Now, phase one is where you would, if you click that, you will actually now refresh your color coding from phase one. So we know red is steering, green is measuring, and that depends on whether you've assigned your impact and control scores to all your connections. And here's your weight slider here. So unlike that very laborious manual process, you can actually just use your slider now to prioritize impact or control, and then hit phase one again, and it will refresh your model and repopulate your coding for you. We also have, you can turn off factor colors, and you can also hide connection decorations as well for a cleaner export. And you can hide tooltips, and I'll talk to you about tooltips shortly, because I think tooltips are really important, and they actually show justifications underneath each factor and connection as to why you've assigned particular scores, and it allows you to flesh out that justification. I'll talk about that. The star factor here, that basically will, once you have loops, will show you the factors that appear most frequently within the model, the factors that are most connected and participate in the highest number of loops. You use the refresh loops button here to actually refresh your loops panel. I'm working through that. It's hard to build software online because of the intensity of and how expensive it is to identify many loops. You've also got themes up here, so you can actually start to theme different factors. So you can click new factor here, and what you can do is you can click here and you can, for example, theme it as economy or use a custom theme if you wish and change your color, but we'll choose, say, economy. safe change, and you can see economy is now around or being placed around this particular factor. And what you can do then is you can group factors. So effectively, once you've got a bigger model, I'll show you, you can start to look at the intra and inter-theme connections between clusters of factors and themes. Like so, and you can also hide the themes if you want as well by pressing themes. You can quick save the model, or you can hard save the model like that to your browser storage. When you actually load the model, it will load all of your tooltips, all of your justifications, your loops, all your coding, and everything like that as well. And you can export your model as a PNG, JPEG, however you wish. So what I might do is I'll just reset the canvas and load in that. Hang on a sec, I've just saved that one, hadn't I? I'll load in another model. Do you want to load a model? Yes. So you'll see here, now we've got a larger model, how the input. So if I prioritize control here and then refresh the phase one, you can see now that patients awaiting mental health treatment is a control-based factor, whereas if we put it to at the impact end, we actually change our classifications. And in QSEM phase one here, you can see that in real time on your system grid as factors move around into the different quadrants, depending on whether you're prioritizing impact and control. And to actually get to the impact and control itself, you actually double click on a connection, and that's how you assign impact or control like so, on time delay like this. Now, when you've actually done that, you can press not reviewed, reviewed, or final. So you can say, okay, I've reviewed that particular connection, and you'll see we have an orange or a yellow circle here. And then for you might be able to share this with stakeholders, send them the QSEM file. Stakeholders might jump in and press sort of final, like they're happy with the scores that they've put in, and then they'll send it back to you. So you can go, okay, it just tells you, which connections are outstanding in terms of have yet to be assigned a score, or which ones have been reviewed or not reviewed yet as well. So it's a really important process assigning your impact control and time delay scores here. And I always tell the groups to always press the little info tab here, because it'll bring up your definitions for you and the questions that are useful in a group model building setting, if you decide to use this in a group model building setting, like so. And you can see here DDM, the direct dependency matrix. That's actually built now automatically in the background, so it'll progress and regress. So if you make changes to the model, update factors, remove connections in the CLD, this DDM is basically the input into both phases. If you remember, it's used in phase one, and phase two loops of interest also uses the DDM as well, for this weighted active score here for generating loops of interest, so impact control and WAS.
Adam,
Yes,
we
I'm
have one
talking a
question.
lot.
No, don't
Yes,
worry.
go for
We've
it.
got one question online from Stephen, and I thought it might just fit to what you just covered there, which he's asking whether the method accommodates different stakeholder opinions or whether consensus is like the only thing that gets you to the final score, I guess. And because in contested spaces, different groups might want to assign different weights or scores to delays. So, like, especially if you don't get, like, if you have a transdisciplinary crowd out there,
Mm.
which might have opposing goals, which is where we use this in dynamics so often. So, do you have a comment on that? Because I just thought it fits to the, like, what if it's not final part? Does it
Yeah,
show up
yeah,
somewhere?
yeah. It's a good question. I think like a level of pragmatism is required, and being scientifically robust with the processes and methodology to assigning your impact control and time delay. So if you're not achieving a threshold of 75% agreement within a group for any given impact or control value, and perhaps it's more you choose, okay, we have one expert in the room who actually knows this particular relationship really well between these factors, will defer and default to their level of expertise. It really is open to however the researcher and practitioner wishes to go about it. I think just recording and being really transparent with that process is the most important thing.
Cool. Stephen, let me know if that did not answer your question.
Um, uh, Thanks, Adam. That's a useful answer. I'm just thinking through in terms of um, the example that I passed on to Miriam was about environmentalists versus say miners who might have a very different worldview. And
Mm,
obviously, one would hope that by the time one's got to the stage, there would be a reasonable degree of consensus. But somewhere along the line, someone might say, well, what if that person sitting over there with a different worldview, what if they were wrong and I was right? What's the different effects, of this? And I understand that the complexity could then increase exponentially. Um, so I'm just thinking through, in terms of I understand your point fully about being scientifically robust. I'm coming from both a practitioner and an academic perspective, trying to understand how one pragmatically bridges that, because at the end of the day, if one important stakeholder group doesn't believe that their views have been reflected in the model, the model's value gets, eroded, I guess. So just wondering from your experience, and I understand you've used the example of the Welsh government, whether you've come across that situation where you've had to try and bridge those views and, the differences have been sustained and just how you've
mm.
dealt with it. Yeah.
Yeah, I think it's a really interesting area and a very good point because I think what you're asking there as well, Stephen, is how you reconcile differences of opinion within a particular setting and making sure that, you know, pe people's perspectives and like experiential insights are accounted for and actually reflected within the model. And I suppose the nebulous answer to that would be like in the Welsh government project, there was a lot of back and forth and dialogue until, generally speaking, the group was happy to move on from that particular um, scoring activity and move on to the next one. I mean, I've been in rooms before where the debate gets quite heated and that you don't necessarily always settle, but I suppose that's when, at the discretion of the researcher, you have to step in and say, okay, perhaps we'll go for this, and here's the reason why this score. Um, I think your guess is as good as mine in terms of how we handle that, and through expert facilitation and protocols. That's how I would probably approach that and ask why. What do you think? I mean, I'm keen to hear your reflections as well and how you'd manage that potential difference.
Um, Thanks for batting that one back to me. The the Yeah, I've just worked in facilitation, not related to modeling, but in other
Mm,
situations where I've come through across different worldviews that were not able to be reconciled through the facilitation process. It's messy, but it happens. And yes, documentation and this is great in terms of being a way to document the thought process and the logic, and so you can sort of show the the transparency of it. The and yeah, so and I understand that it's a broader issue than simply QSEM, but it's like, we've got such a big focus
mm.
on participative modeling in terms of best practice for system dynamics, and I'm just thinking through the messy bits of it, like how does one actually navigate? So, and I appreciate that there is no one answer, but thank you for taking the time to at least take a stab,
There is actually, Stephen, that something I've tried to do here is first under the factor database here, just like adjusted workforce productivity rate, I might say, you know, um, this factor is defined as, and
Yeah.
lock that in. And then you can show that here. And when you click it once and then re-hover over that, you can see the floating tooltip. Likewise, for the link database, if we were to provide a justification here, lock that one in. And for the control, why did the group consider that level of control to be important? And here for the time delay, If you then click show and then again like click the link and rehover, you'll actually see a floating tooltip where people can start to understand why they may have assigned those. But maybe that's the best we can do when it comes to sort of either reconciling or making those differences transparent.
I'll let you know.
Oh, yeah, let me know. Yeah, that's a good one.
Thanks. Thank you.
No worries. I think I'm nearly there anyway in terms of the demo here, and then perhaps I'll be quiet and open the floor up because we have plenty of time. And just to finish that off, there's phase one. In terms of phase two, remember to hit refresh loops for the time being until we sort of iron out a few constraints with the model. Refresh the loops, and you'll see here that we have 31 loops in total in the model. You can collapse down the loop categories like so, as well as down here as well. You can actually expand or collapse all the reinforcing loops. And then once you have your loops registry open, you can go to phase two and you can identify all of in the dynamic loop register, all of your loops in the model. And you can, so depending on if you wanted to sort of highlight, I want to look at loops of control that happen to be very strong, or you can actually press, fast control loops, or you can use your preset buttons if you wish. I like to use the sliders like so. The dynamic loop register will resort, and then you can press this little highlight button here, and it will take you to that particular loop there, and that's when you can sort of add a label, if you will. So you can sort of highlight your loop and add your label. I've yet to allow some text editing, so you can actually offer a name as well for that particular loop, so you can understand. Maybe it's the top control loop with the strongest level of control, and you can add your own label to that. So that's the dynamic loop register there, and you can sort by reinforcing, balancing. Obviously, we don't have any unclassified at the moment, and that's where you can identify your longest independent loop. So if you put independence up to 100%, if you click this, B1312 happens to be, relatively speaking, sort of the longest, most independent loop within the model itself. Again, look, it's just providing that transparency and that reasoning as to why you've identified that loop that could be of interest. You'll also see that now we have a model. The adjusted workforce productivity rate happens to have, by pressing this star factor in your toolbar, happens to be the most connected. It's part of 21 loops in total, which is 68% of your loops. You can turn that off by pressing phase two if you want. You can hide all your notation like so, just for for clean model presentation and so forth. And then if you wish to, it's just a bit of I found that it's nice for stakeholders if you wish to identify quickly with them. Press time delay here. That uses the QSEM influence propagation system grid. This is actually time delay. It just gives you an idea of where the slow propagations are and the faster propagations within a model, like that. And then you just press this again to go back to your 2D screen. So I'll stop there, Miriam, because I think that's a nice little overview of how the software works in case people were interested. But if there's any other questions, I'm happy to try my best to provide any answers.
Fantastic. Ooh, my head's brimming. It's a lot of new stuff. I'll have some questions, but I'd love to bring it to the floor first because I think some people need to run to where does have lunch breaks or meetings. So any questions on the floor? On the online floor? Please don't be shy. Just unmute yourself and go for it. Hossein?
Yeah, I can ask actually two questions. One is that was fantastic. I have played with the application once before. It is fantastic, specifically when you don't have enough reliable time series data to develop the simulation model. Then sometimes having this approach instead of just showing qualitative causal loop diagram, it adds more to the CLDs. My question is, The first one is you had a couple of parameter values in the backend. Can we update those values uh, in the app, or it is just coded, hard coded in the application?
Yeah. Do you mean these, Hussein? The when you assign from the direct dependency matrix, like here, for example, can you update
Mm.
these? Yeah. At the moment, it's one way, because the matrix can get really large. If this is what you mean, you might be able to update this 3 here to a 2, and that's reflected in the model. Currently, it's model 2 DDM, not the other way. Is that what you mean there?
I mean, in your analysis in the Excel file,
Oh,
you
yes.
had a couple of parameter values. I just wanted to know if we are able to change them or not.
Yeah, they're all hard coded into here now. So
Okay.
you can, so this, those parameter values in the Excel spreadsheet, you can see like 80% here is given to impact, 20% to control.
Yeah.
That's what those were in the Excel
Yeah.
spreadsheets, but now in the form of a slider here.
Okay. Okay. That's good. Uh, Another thing is the which is the debate these days using AI. I was wondering a couple of the steps that you did already in this example could be supported by AI, at least for. I mean, AI can give us if you can give it good reference to seek for the scores you're going to give here
Hmm.
and the perspective you're following toward the problem, then it can give you at least the initial value, then you can revise it. Or what do you think?
Oh, I think I've given a lot of thought to AI, and I think if QSEM doesn't keep pace with the AI revolution and embed AI, and I have ideas, of course, of how it could work, then it could potentially fall behind, because it's just we're in this AI explosion at the moment, this revolution, and I think that how it could be used, without saying too much, but perhaps for identifying particular structures in the model, as well as, like you said then or alluded to, supporting people with justifying scores and weights, and also integrating it, by bridging that gap between data that might exist on the web that's readily available, and then QSEM itself, so linking that in. But I know Stella and others have taken huge leaps in this regard, and it's fantastic, and supports people, especially with loops that matter in that case and things. So I think, yeah, it would be nice to be able to look at it here, because I think the idea is to really help people enjoy modeling. Like that's the whole point of QSEM, is to help people enjoy it. And if AI plays a role in that, it would be wonderful.
Perfect. Perfect.
I've
Without removing the thinking,
mm,
you still got to think. It's really important, isn't it?
Yeah, yeah.
Yeah.
sort of like the baseline. I've got a couple of questions as well in case someone like yeah. One is, and I know that like I have a feeling you've explained part of that already through the time delays, but I think one of the most contested areas in CLDs is the not really seeing loop dominance shifts. And so I'm just curious whether you find that the time delay that you have there helps people to assess that to some degree, or
I'd love to. It's a good question, Miriam, and I'd love to be able to say, oh, it helps with shifting dominance and so forth. But this is firmly within that participatory
Mhm.
SD space, and um, I'd be using Stellar
Okay.
loops that matter for
Mhm.
loop dominance. Yeah.
Okay, cool. And then second question might be equally quick and very important for, I guess, both practitioners and researchers, but is what does it export into?
Yes.
Do you have high res? Do you have adjustable, like, yeah, how big is it?
Yeah. Yeah. It's yeah. No. That's good. It's high res in terms of PNG and JPEG. I'll move this over the screen here,
Mhm.
like so. Hopefully you can see that's popped up. Is that legible there? Uh,
No, we don't see the change in
Not that
screens.
one.
We're
Let
still
me
in
just.
your,
Okay. I'll make sure I.
I'm happy to take your word for it though. Like, yeah, it's
Yes,
just
yeah, I've got
because
to.
you would know about like a high res in journals is very important that they can read everything. And equally, if you have a CEO who squints their eyes, they're not happy about it. So it's like, yeah, it's like, does it import
Yes,
into different?
yeah, it's as you can see there, that's
Okay,
the PNG version, and you can export that in the a journal article or whatever you
okay,
wish.
sweet,
Yeah,
great.
seems to work
That's
well.
for me for now.
Thanks, Miriam. They're good.
Any other questions? Beth left another comment in, I think she just left it when she left. Yeah, around have a read. I think adding to the conversation between Stephen and you.
Yeah,
Um,
if there's any others as well, I can. I'm very happy to get back to people and answer any questions and so forth. Not a problem there. And indeed, do reach out. There's other questions that may arise. After you finish a webinar or dabble with software, or there's things that arise in the moment. I'm happy to help if I can.
Great. Yeah, wonderful. Well, we don't have any more questions. I'm just going to make a point because I think one thing I love about the scoring system is that you actually can identify areas where there is no consensus, and a good facilitator would then pick that up and I guess initiate a different kind of conversation around those because there could be interesting points for a different kind of conversation, like besides the modeling, but adding decision making nonetheless.
Yes,
Um,
yes. And I
Yeah,
wanted to.
and also one thing I found with the discussion with Stefan and yourself was that the benefit of this application then would be to put different values and the scores and show the difference of outcomes at the end to see how different values could result in different outcomes. And if it is kind of in terms of quantitative modeling, it is kind of sensitivity analysis to see what is the impact of changing one value on the outcome.
Yeah.
So that could be helpful actually to see, okay, if these two stakeholders are not happy with this value or that value, then let's see what's the impact on the outcome. If it is
Mm.
not too much impact on the outcome, then we'll be happy to go with either.
That's exactly right. Yeah, just changing the actual scores themselves or the coefficients, that are given to the impact and control you can instantly see those changes and I think what I've learned or I'm continuing to learn is that it's the rich discussions that I had, like you say, saying like when you change those values in the moment as to what the end user actually says next, and how it helps them is where I get excited and happy with what's produced to encourage that discussion.
right.
Yeah,
Well, thank you so much. Is there more questions? No questions? In the count to three,
I think
quietly.
that's it.
Great. Thank you so much, Adam. And yeah, just another plug. I think if we're going to have the symposium next February 5th and 6th of February to come along, and we'll have more of these webinars next year. I think we'll have a break for this, and hope everybody has a good run up to the silly season, and have a good summer break. Yeah. Thank you, Adam. Thanks for saying.
Thank you,
Thanks
Adam.
everyone
Thank
for
you,
coming.
everyone.
Thank you. Thanks,
Thanks,
everybody.
Adam.
Appreciate it.
Well done.
Yeah,
Thank you.
thank
Very
you.
happy to have you.
Thanks.